Welcome back, everyone. One more time, your instructor Oscar Rodriguez here with the principles of ladder logic programming for PLCs. We are now on the applications portion of this ladder logic programming course, and this time I'm presenting to you a timer motor control. We spoke about timers and how they work, and we said that they're word-based instructions, and they can be found over here where it says timer counter. That's what timers are. We studied the tone, the tough, the retentive timer, and notice that the counters are also in that part. There's also a reset instruction that is part of that. Anyhow, here I have a system that does a timing based startup motor control system. In other words, we're going to have a number of different outputs that we want them to not be energized at the same time, but we're going to add a timing device that will allow us to time up how and with what time interval the outputs will be energized. So notice that we have here the traditional start stop with an output, in this case the pilot light, which could be the wire that connects the control system of the motor. And I should say it again, never connect loads directly to the controller. We've been saying that for a long time, and I hope you get that point, because I don't want you to burn or be in trouble because you're connecting big loads to the control system or the PLC. PLCs are control devices, and they actually handle very low amount of current, up to 2 amps. In my case, I have just pilot lights connected to my terminals. If I was to control a big load, I have to go through a interface system, which we haven't talked a lot about that. But you want to read the PLC's manual to see how the control terminals of your PLC can interface with the actual load system. All right, so that's a word of caution. Back to our drawing board, and so we have here a traditional start stop, and we have here, notice also other outputs that are being driven by the bits of the timers. And in this case, we got multiple timers. I think we got two timers. Yeah, and two timers, those timers, what they'll do is they're gonna energize the system in a sequence. All right, if you look at the timer tables, you recognize that we have timer 40 and timer 41, and we also have the dawn bit of those timers working for us. Let me see if I can minimize this a little more so you can see a little more. And we can observe this. It's going to be tough to see everything, but we can observe how this works as we energize. So let's go ahead and download it to our hardware system here. And as we do that, it should go on. And in this case, we're using the on delay timer, which is basically one that is energized. And as it does so, it times. I've added a preset value of 5, so let's go ahead and get started. Start, and notice that the timer is going on. The second output will be energized 5 seconds after. The third output will be energized another 5 seconds after the next one. So we have a time-based sequence of motor being driven by this time or timer-based program. Let me see if I can minimize that so you can see it all. There you go. I think that's all. All right, so let's run it one more time. Stop. I'm going to start it, and I'm going to let the timers do their time, and you can see that the outputs are coming on after interval time of 5 seconds. This is very typical where you have multiple loads that they will drive or they'll consume a lot of juice or power, and you don't want those loads all coming at the same time. You want to be able to steadily and timely energize those loads. And this will be an example of a timer control event or output to be energized. All right, once again, you need to mess up with this so you can play with this. I'm going to provide you a PDF file and also the ladder program. Notice here that the sequence of my runs will not make a huge difference in where the timers and where the lows are. I can actually exchange this. I'm going to put the timer up, and I can put both timers in sequence, and I can have my two lows down below, and this is not going to make a difference in the way the timer will behave or work. However you want to do it, there's no right or wrong design for when you're using timers and counters instructions. You can put them anywhere they want. These are computer-based instructions. They can work anytime. So here I go once again. Energize. Notice the timer, first timer going on. Energize the second output. And then the next timer will do the same for the third output. And then we'll stop the system. Likewise, you could have all the outputs on top on the first rungs like that, and the timers below, and that will not make a difference. You can actually modify this however you want. Okay, one more time. I'm going to run it, download it. All right, and once again, I'm using my hardware. You can use your simulation software. If you have a piece of hardware, you can do that too. And here I go one more time. First load start right on when I press start. Second load goes 5 seconds after, and then the third load goes another 5 seconds after. And then of course you start and end the process whenever you want. How's our video doing here? It's getting nice. All right, so with that, once again, this is what we did. We added a ladder program that does the same that this electromechanical system is doing. And so here we have a start, stop. We're using electromechanical control relays for the relay logic system here, and we converted these from a relay schematic system to a ladder logic based system. Once again, I will provide you the PDF files for this file so you can review them, redo them, and do whatever you need to do. So this is your instructor, Dr. Rodriguez, with the Principles of Ladder Logic Programming course. Excuse my noise here, and we're going to stop here so we can come back with the next